Hello, my name is Isra, and we are going to be doing question number 62 from chapter 4 in our book, and we can just go ahead and get started. I put a periodic table here just so we can refer to it if we need to for valence electrons. So let's start with A. The question reads, determine the formal charge of each element in the following. We've got HCl, CF4, PCl3, and PF5. Just a little before we get started, shortcut or hint that I was taught by a lab tech at RVCC during a lab. He said that the best way to look at it, just to think quickly, is to look at the atom and think about how many valence electrons the atom comes in with, subtract that number by the number of valence electrons it has left over after it's done bonding, and that's it. And that gives you your formal charge, but I'll show you what I mean once we get to them. So HCl. How many valence electrons does each atom have in this molecule is what we have to do first. So hydrogen has 1, chlorine has 7, which gives us 8 valence electrons. Now we can kind of draw our structure, and we can see whether we can just make sure that our electrons were used up. So there's hydrogen's 1, and then chlorine's 1, 2, 3, 4, 5, 6, 7. And we don't have any more electrons left, so we're good. Now we can go ahead and figure out the formal charge. So what I meant when I was talking about this hint was, so you would look at your hydrogen and you'd say, how many valence electrons does hydrogen have? We look at the periodic table and we see that it has 1. Since hydrogen has 1 valence electron, you would write that 1 down. And you would say, how many valence electrons does hydrogen now have after it's done bonding? It still only has 1. And the way I kind of used to do it when I first started, I used to box my atom just so I'm only looking at that atom. And it still has 1, so 1 minus 1. The number of valence electrons it had, the number of valence electrons it still has now after bonding is 1, which equals 0, so our formal charge for hydrogen is 0. Now we're going to do the same thing with chlorine. The number of valence electrons chlorine has, if we look at our periodic table, is 7. And then how many valence electrons does it have now? 1, 2, 3, 4, 5, 6, 7. And that gives us our 0 formal charge. And that's it for the HCl. And this is a good molecule because we have 0 formal charges, we don't have high numbers, no pluses on electronegative elements. This is how we want it to look. Let's do the next one. Carbon has 4 valence electrons plus 7 for fluorine times 4 because it's got 4 fluorines, which would equal 32 valence electrons. Now we can kind of draw our structure. And we can put our, we can subtract actually the number of bonds that we have here from our valence electrons, so we see how many electrons we have left over. So that's 1, 2, 3, 4, 5, 6, 7, 8 minus 8 gives us 824. And we're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And that uses up all of our electrons. And now that we're done with our structure, we can go ahead and do the formal charges. So the same way, how many valence electrons does carbon have? We see here it has 4 because we already determined that. And how many does it have now? It's got 1, 2, 3, 4. And so the 4 minus 4 would give us 0, and that's our formal charge for carbon. Now let's do one for fluorine. Fluorine came in with 7 valence electrons, and it now has 1, 2, 3, 4, 5, 6, 7. So 7 minus 7 gives us 0, and fluorine has a 0 charge. We are not going to do the formal charge for the rest of the fluorines because they're bonded exactly the same way as this one is, so we know that all of them have a 0 formal charge. 1, 2, 3, 4. And then that one's for that. Okay, so that's it for that one. And it looks great because everyone's got a 0. There's no high numbers. There's no pluses on electronegative elements. We're okay with that. Now let's look at the next one. And now let's figure out how many valence electrons phosphorus has, which I should have done first, but phosphorus has 5 plus 7 chlorine times 3, because we have 3 chlorines, which would then equal 26 valence electrons. Now we used up 1, 2, 3, 4, 5, 6 of them, which leaves us with 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now that we've put the electrons on all of the outer atoms, where would we put the leftover 2? We would put them on the central atom. So 1, 2. And now we can go ahead and do our formal charges because we've already put all the electrons where and filled it out. So let's see. Phosphorus came in with 5. And it now has 1, 2, 3, 4, 5. So 5 minus 5 gives you a 0. So we now know that our formal charge on the central atom is 0. Now let's do chlorine. And again, we're only going to do 1 chlorine. We're not going to do the rest because the other 2 are going to be the same as they are bonded the same way. So chlorine came in with 7. It now has 1, 2, 3, 4, 5, 6, 7. 7 minus 7 gives us a 0. And that's our formal charge for our chlorine. And this is all looking like a good molecule because there's no plus 2s or plus 3s or plus 1s, and everything looks good. Now let's do PF5. Phosphorus has 5 valence electrons plus 7 times 5, because we have 5 fluorines, would equal 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus 10 would equal 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 26, 27, 28, 29, 30. So we used up all the leftover 30 that we had, and we're good. So now we can go ahead and try the formal charges. So let's take a look at the central atom, which is phosphorus. It came in with 5 valence electrons. It now has 1, 2, 3, 4, 5. And so our 5 minus 5 equals 0. And just a reminder, 5 is what phosphorus came in with. That's how many valence electrons it has. And after it's done bonding with the other atom, it's now left with 5 as well. So 5 minus 5 would give us 0. And now we can do a fluorine. So fluorine came in with 7, and it now has 1, 2, 3, 4, 5, 6, 7. 7 minus 7 equals 0, and now we know that our formal charge for fluorine is also 0. And the rest are going to be the same because, again, like I said before, they're bonded the same exact way, so there's no reason to have to do it again. They're all going to have the same formal charge. So this one's also a great molecule. Now, just for the sake of you're not always going to get 0 formal charges, and I want you to understand that it's not always going to be that simple, and the reason why formal charges are important. So I'm just going to do a quick extra example of sulfate so you understand a little more about formal charges. So if we look at sulfate, we're going to first do the valence electrons. We know that sulfur has 6, plus oxygen has 6 times 4, plus the 2 electrons that it brings in, which would give us a total of 32 valence electrons. And we'll kind of draw the structure out. We'll do it right here. And now that we've used up 1, 2, 3, 4, 5, 6, 7, 8, we're going to subtract 8 from it. And we'll have 24 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we've used up all of our electrons. So now if we take a look, let's do the formal charge. If we do the formal charge of this sulfur, the central sulfur first, so first we're going to take a look at how many valence electrons sulfur came in with, which is 6. And it now has 1, 2, 3, 4. So it doesn't have 6, it actually has 4. So 6, we'll do it right here, minus, so 6 is the number sulfur came in with, and it now has 4. So 6 minus 4 would give you a +2. And that becomes the formal charge on sulfur, which we haven't seen yet, but this is important. Sulfur is a very electronegative element, and seeing a +2 on it is not a good thing. We don't want it to have a +2 charge. We'd be okay with a minus charge or 0, but +2 definitely doesn't make it a stable structure. So let's do oxygen now. Oxygen also comes in with 6, so, and 1, 2, 3, 4, 5, 6, 7, and now has 7. So 6 minus 7, which equals a -1, which we're okay with because it is an electronegative element, a very electronegative element. And now that that's done, we can go ahead and write it properly with our 2-, but this structure does not look good to us. We've got to figure out a way of getting rid of that +2. And the only way would be to take one of these electrons and kind of share it with the sulfur to create a double bond. So let's try another structure. Double, and the rest will stay single. And because we used up one of the pairs from this oxygen, we're now going to only have 2 lone pairs on these, and we're still going to have the same amount on the rest because we didn't make any change to the rest. Now let's do the formal charge for sulfur. Sulfur came in with 6, and it now has 1, 2, 3, 4, 5. So 6 minus 5 equals +1, which is our formal charge on sulfur. The formal charge on these 3 oxygens is going to stay the same as it was in the other ones because there was no change made. But the formal charge on this one is going to change. So oxygen comes in with 6 and now has 1, 2, 3, 4, 5, 6. So 6 minus 6 gives us 0. So that's your formal charge on this oxygen. So things are starting to look a little better, but we still don't want our sulfur to be a +1. So let's try one more structure. The next thing we're going to do is we're going to take a lone pair from this oxygen and create a double bond to see if that helps in any way. So we're going to leave 2 lone pairs because we used one up here, and 2 lone pairs on this one because we used one over here. And the rest will have the 3 because there was no change made. And now we're going to do our formal charges again to see what goes on. So sulfur came in with 6. It now has 1, 2, 3, 4, 5, 6. 6 minus 6 gives it a 0. Formal charge. Now we can look at the other one. Looking at the other one, we know that the one with 2 lone pairs has a +1 charge because we already did that. So this is going to be a +1. This is going to be a +1. I'm sorry, not a +1. It has a 0 charge. A 0 charge because oxygen comes in with 6 and now has 1, 2, 3, 4, 5, 6. So that's 6 minus 6 is 0. This is going to have a -1 charge and a -1 charge because of the oxygen comes in with 6 and it now has 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is -1. This right here would be our most favorable or most stable structure because sulfur is electronegative. It doesn't have any +1s or +2s as charges on it. It's got a 0. That's what we want to see. Oxygen's got a -1, the 2 oxygen on the side, which is okay because oxygen is electronegative. These 2 oxygens have a 0. That's okay as well, as long as we don't have any pluses on the electronegative elements. So our best molecule would be this one, and that's why formal charges are important. I just wanted to show this example. Thank you for patiently watching.